The unit that I have selected for this application is functions of two variables, and I have chose optimization for my application problem. For the example that I've put out is find the first and second partial derivatives of f of x, y is x to the power of 4 plus 2x to the squared times y squared plus x cubed times y plus y to the power of 4. To find f of x, we would do the derivative of the first portion, which would be x to the power of 4, which would be 4x to the power of 3. And then for the second portion, we would do the 2x squared, which would be plus 4x. And since it is attached to y, it would just be 4x times y to the power of 2. And for the next portion, we would add 3x squared, and this is also attached to y, so we have to keep y. And since it is just f of x, we will leave out y to the power of 4, and our answer for f of x would be 4x cubed plus 4xy squared plus 3x times y times 2y. Or I mean 3x squared times y. To find f of x, we would just do the derivative of x in f of x, which would be 12x squared plus 4y squared, and this is because the derivative of the x in 4xy squared right here would just be 1, and that would make it 4y squared. And the same applies for this 3x squared y, which would just be 6xy. To find fx of y, we would find the derivative for f of x, which would leave us to leave out 4x cubed, and it would make it 8xy. Since we have y squared, we would multiply the 2, and since it is attached to 4x, we would multiply the exponent by the coefficient in front of everything, which would be 2 times 4, which would make it 8xy. And for the second portion, it would just be 3x squared, because the derivative of y when it's attached to 3x squared is just 1, which would just make it 3x squared. To find f of y, we would find the derivative for the y, and that would cause us to leave out x to the power of 4. But since for the second portion, the y squared is attached to 2x squared, so it would be 4x. F of y would be 4x squared y. And then for the second portion, it would be x. It would just be x cubed, since y, the derivative of y is 1, and then for the last portion, it would be 4y cubed. To find fy of y, we would do the derivative. We'd find the derivative of the y inside of f of y, which would just be 4x squared, and we leave out the x cubed because it's for y, and then it would be 12y to the power of 2. Finally, to solve for fy of x, we would just find the derivative of x for the f of y, which would be 8x times y plus 3x to the power of 2. And then for the last portion, it would be 12y squared.